So here is question number 21, everyone. Three uniform identical rods of mass m and length capital L are arranged as shown in figure. The location of center of mass will be what? Now we know that for any rod, whole its mass concentrated at its geometrical center, that is at the midpoint. So masses will be concentrated at these points only. We only have to find out the location, the coordinates of these points. For this point, coordinates will be L by 2, 0. Why coordinate 0? Because it is lying on the x-axis. For this, x coordinate will be 0, y coordinate L by 2. And for third rod, x coordinate will be L by 2 undoubtedly, but y coordinate will be what? This length will be the y coordinate. Now that will be what? This is L by 2 and this will be L by 6. So the y coordinate will be L by 6 plus L by 2. That gets you 2L by 3. Now we have got the coordinates, we have got the masses. We can calculate x center of mass as well as y center of mass. XCM is what? M1 x1 plus M2 x2 plus M3 x3 whole divided by M1 plus M2 plus M3. M L by 2 plus second x coordinate 0, so 0 plus third M into L by 2 again divided by total mass, that is 3M, gets you L by 3. Similarly, y center of mass will be M into 0 plus M into L by 2 plus M into 2L by 3 whole divided by total mass, that is 3M. After solving, this gets you 7L by 18. So from here we got the coordinates of center of mass, that is L by 3 and 7L by 18. So when we look at the option, we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Now let us proceed to the next question, that is question number 22. Here is question number 22, everyone. An ice skater having moment of inertia I naught rotating with angular speed omega naught suddenly opens his arm, causes angular speed reduced to omega naught by 3, then what will be the percentage change in moment of inertia? Now, since there is no torque acting from the outside, so we can say that angular momentum will be conserved. Angular momentum of skater will be constant or conserved. Means L1 must be equal to L2. L is what? I into omega. So I1 omega 1 equals I2 omega 2. I1 given that I naught, omega 1 omega naught equals I2. We have to find out omega 2 is omega naught by 3. Cancel out, we got the final moment of inertia is thrice the initial. So percentage change in moment of inertia will be what? I2 minus I1 whole divided by I1 multiplied by 100 gets you 3I0 minus I0, that is 2I0 divided by I0 multiplied by 100. So percentage change in moment of inertia is what? 200%. So after looking at the option, we can say that option number 1 is absolutely correct. So we will go with option number 1 only. Now let us proceed to the next question, that is 23 number. So here is question number 23, everyone. A disc is performing pure rolling between two moving planks as shown in figure. The velocity of center of mass of the disc will be what? Now the pure rolling situation is directly mentioned here. So we can say that the object, the disc, has translational as well as rotational motion. Its center of mass is moving forward. So here the speed will be what? VCM plus of r omega. On the other hand, the speed at the bottom, at the lowermost point, will be what? VCM will also be there, but due to the rotation, there will be a backward speed, that is r omega. So the speed at highest point, that is V1, will be what? VCM plus r omega, because they are in same direction, horizontally forward. On the other hand, the speed at lowermost point V2 will be what? VCM is forward, but r omega is backward. That's why it will be subtracted. V1 is given 2. So 2 equals VCM plus r omega. V2 is 1. So 1 equals VCM minus r omega. Adding them gets you 2 VCM equals 3. So velocity of center of mass will be what? 1.5 meter per second. Option number 1 is absolutely correct. We'll go with option number 1 only. Move on to question number 24. So here is question number 24, everyone. The force of gravitation on an object F is proportional to 1 by r to the power 6. Then the orbital velocity and time period of object will be proportional to what? Means how they will be proportional, or how they will depend on r. Now we know very well, in case of orbiting of satellite, the centripetal force will be provided by the gravitational force F. So the gravitational force F that will provide the necessary centripetal force Fc is proportional to what? 1 by r to the power 6. Fc is what? mv square by r, which is proportional to 1 by r to the power 6. Cancel out r to the power 5. Mass itself a constant value, so we can have v proportional to r to the power minus 5 by 2. So this is the relation of v with r we just have got. Orbital velocity. Now for the period of object, we know that the time period of orbit is given by 2 pi r divided by v. Means t is proportional to r by v, which is proportional to r. V is itself proportional to r to the power minus 5 by 2. So therefore we can further write t proportional to r to the power 1 plus 5 by 2, or t proportional to r to the power 7 by 2. So this is for time period. So if we look at the option, we can say that option number 3 is perfectly matching. So that's why we will go with option number 3 only. Now let us proceed to the next question, that is 25 number. Here is question number 25, everyone. A spherical planet has mass capital M and diameter capital D. A particle of mass MP is falling near the surface of planet. Due to the falling particle, the planet will experience an acceleration equal to what? We know very well that the gravitational force of attraction between two particles is mutual, and both will experience the same force. Now suppose this is the planet near the surface of which the particle is falling. Now both will exert a same force of attraction on each other, which can be written as gravitational force Fg, that is g, mass of one particle, mass of another particle, divided by r square. Now r will be what? The radius of the planet, that is d by 2. So d square divided by 4. This force will be experienced on both. So Fg will be what? 4g mass of planet, mass of particle divided by d square. This force will also exert on the planet as well. So therefore the acceleration of planet having mass m, am, will be given by Fg divided by mass of planet, that is 4g mp divided by d square. So that will be the acceleration act on the planet. And after looking at the option, we can say that option number 4 is absolutely correct. So that's why we will go with option number 4 only.